Okay, welcome everyone to our education working group for today, Tuesday, May 5th. I'm going to share my screen, and so Tomislav will be leaving us at some point during this session here. So I want to get oriented as far as what we can and cannot do during the hour. So so we've been carrying, on the agenda, I've carried over some items from the last week and from the previous weeks, as far as things that we've been talking about and what we would like to discuss. So talking about the code in RChain project, so that's going to be more of a, we'll need assistance from a core developer like Tomislav, as well as maybe the debugging in IntelliJ. And then RChain, maybe some week we can coordinate with Will. Now, Will is in China, so although it's 10 a.m. here, New York time, it's 10 p.m. Beijing time. Tomislav, what's your thoughts on, do you think Will would join us, or how would we get Will's participation, or is it needed? What are your thoughts on RChain for a future session?
Yeah, I think he can join. I think it's not too late for him.
Okay, well, what I'll do is I'll reach out to Will and see, just kind of see if he can join us at some point in the future. Okay, so we have talking about the RChain code, project code, or IntelliJ. Any preference from anyone, or Tomislav? What do you, based on your schedule here for the hour, what would you like to do or focus on?
So I would like to just say like introduction to Tagus Final, what we are using in Scala. And, you know, I want to hear some kind of feedback, and, you know, because I found out very nice post by John DeGo about his library Zio, and he's comparing this to Tagus Final. And so I would like to go through this article and just, you know, point some like main things what he was you know, trying to say.
Okay, very good. So go ahead if you'd like to share your screen and share the article.
So can you give me a few minutes before that? I'm just
sure.
looking for image that we want to publish on Minute.
Yeah,
so.
Very good. Hey, Jim, welcome.
Greetings.
Yeah, I went ahead and claimed host and started recording.
Oh, I thought I was recording.
Well, we're both recording. I have a few additional minutes of the session. So I have, cool. I did an introduction.
I didn't see the recording thing.
Yeah.
So I'll stop mine.
Okay. So I'll post it.
Okay, yeah, I see it.
Yeah.
I didn't know two people could record.
I was quicker to the draw, so be careful when you're around me, okay? Yeah. So let's see here. Oh, and thanks, Arthur, for last week for your overview of all the work you've been doing. So that was very helpful. Just to kind of give a little background, so there's the core development team, and then there's the development going on in the community. So for community features and development that the community or individuals in the community like to have implemented in the RChain code base, there's a process to go about doing that, and that process is called the RChain improvement process, or RChips. And it's it was something that was created a year ago. The first version was rather formal, where there's a summary or a proposal is created. It's submitted to a committee, editorial committee. Then there's an approval committee. It's rather arduous, but now because we're a bit thin in ranks and numbers. Basically, if you have an improvement that you'd like to see to the RChain code base, go ahead and write it up and submit it to the dev team, or to through perhaps RAW, and we can kind of work through that channel for creating a RChain improvement. So I just wanted to share that. Let's see here. Let me share my screen. Just so let's see here. So in the does everyone have access to our education folder? There's only 4 documents in there right now, but they're this is kind of the repository. It's a shared folder, so hopefully everyone should have access to it. Let's see here. Some of these I haven't looked at in a bit. Node monitoring. Okay. Is Theo? Let's see here. Theo, since you're on the call, I was just wondering if you've been thinking about node monitoring tools. Have you been doing any thinking or coordinating on that by chance?
Yeah, not since last week, after the network issues and stuff.
Oh, that's right. So
yeah.
I got to keep in mind that this past week was pretty intense. Raul says it was kind of like launching another mainnet. So okay, yeah. Thank you.
So it was, especially when like some nodes kind of have to be restarted. It's like, yeah.
Yeah. So here's our RChain Scala educational series. So in some of the discussions that we've had in the previous weeks and in tech governance, we kind of put out some goals here. So this is we're at the beginning of May, so we're in the second quarter. So I don't know how realistic these goals are, but these are kind of what was mentioned in some of the previous sessions as far as what we hope to do in the second quarter. And if we don't accomplish them, basically we just move them to the third quarter, because you can only do what you can do. So but let's see here. So we talked about creating some short videos, some sketches, Tuesday sessions, playlists. So that's actually something that here, let me, something I should be doing, creating playlists in the, in YouTube. And actually, there's Joshy's Rholang hours can be a playlist as well. So, voting DAP creation and education. Okay. Report results, detect governance.
Hey, Steve.
Yeah.
It's Arthur here.
Hey, Arthur.
You know, what I'm, you know, as you know, I'm working on app, and just above where you've highlighted voting DApp creation education,
Yeah.
it'd be really nice to add app there as well. You know, you want the app and the DApp. I'm finding a lot of stuff on DApp creation, but not kind of putting the app and the DApp together. So if you had a voting DApp and an app, it would help.
Okay.
It kind of broaden it out a little bit more.
Yeah, bear with me here. So is it in this, in the, the voting app?
Right.
And voting, there, I should say there, this was in, related to, there's a, it's called the, help me out, Jim, the RV, here, the RV 2020 voting DApp. That there's a specific DApp that the Colab community is creating, and Jim's actually started on it.
What's the app that's going to interact with that?
Jim, he could probably speak to that.
Well, I think it's going to be a decentralized application. I don't think it's going to be centralized. Are you suggesting we need a centralized? I mean, part of it could be centralized.
No, this is an education question. I mean, what I'm finding is that I know how to build dApps now. dApps I can do. What I don't know how to do is build an app to interact with the dApp.
Yeah, that's terminology is probably, a dApp should have an interface.
Yeah, that's what I'm saying. It's like every,
That's not considered a separate application. The application is either centralized or just decentralized.
Okay, whatever we call it, what I'm saying is that there's a lot of information on building dApps, right? I mean, but there isn't enough information on how you build UI on top of those dApps so people can actually use them. There's toolkits and stuff like that, but there isn't, you know what I mean?
I don't know. Does anyone else think there's a distinction there? I don't think there is. I think a dApp without a user interface is not a dApp. It's not a dApp.
Okay.
Yeah.
So Arthur,
go ahead.
are you thinking about dApp as a contract on RChain?
Yeah.
Okay.
So you see your dApp as both UI and contract. Okay.
Yeah. We usually we see it like that. Yeah.
Oh, okay. So what I'm saying is that there's not enough about the UI interacting with the dApp.
Yeah, and this is exactly the point of these education sessions. I wanted to say that I was thinking that, mostly about other languages than Rholang for these education sessions, right? Because the first you want to know how to just interact, right, with your own language and with your own application, and you don't care about Rholang and contracts,
right?
Because they're also difficult to write, and at least now we don't have type system and everything, so we will be mostly writing not Rholang code. So yeah, I agree.
Good. How are you coming along, Tomislav? Were you able to bring up the web page you were going to reference?
Yeah, I can share my screen, and so I want to talk about this article. So this article is really about this interaction between how we write code, right? We are writing some data flow, and we are writing some control flow, right? We want to specify, how the data in our program is going through one function to another, and this is what is important for us. But when we are doing that, we are forced to also write how the control of the execution will happen, and this is where things becoming difficult, especially when programs are concurrent, and it's not very clear when you look at today languages, how these two things are separated, right? So for example, if you take a look in this kind of program, right? For example, this kind of program. I'll make it a little bigger. This is like very nice representation of control flow of execution, and also the flow of the data. And we can also say that this program is completely pure, because we are not using anything outside of scope that is created here. So when we are saying, oh, I'm calling a console put string, or I'm getting something from the console, we are not really calling the console of our virtual machine. We are just calling the something that we are having here as an argument. So this is one dependency to our program, and this dependency controls the data, right? We are putting something in the standard output, or getting something from the standard input. But what is about this monad here? So this monad here is not about the data. It's about how these expressions that we have, how they will be executed. And monad are saying you can use for comprehension. So you can sequentialize execution. So whatever we are depending here as a console for our data, we are saying with monad, oh, I will execute this in sequence. I will execute something first, then second, right? And this monad tells you, you cannot do this in any other way. You are forced to do this sequentially. And we are completely used to this notion of, we are writing programs sequentially and they are executed sequentially. So, but, and this is why Greg is saying monad is a new object, right? Because in this style of writing programs, we are always specifying both part of the stories, right? The execution flow and the data flow. And the monad is what we are used to in all languages practically, right? If you write JavaScript, you don't see this monad. You don't write it anywhere, but it's there because a semicolon is like separation of each expression. And in Scala, writing in this style, we are also doing the same thing. But semicolon is our monad, right? Because each of this line is like a semicolon. We are saying, oh, execute this, then after that execute this, and this name is available in our next command. So essentially we had completely the same thing as normal languages when we are writing semicolon. So this is something that I want to point out. When you look at the arguments of the function, you're really specifying all the dependency that this function needs. And when we are talking about correct programs, we are really talking about or pure programs. We were really talking about we have all of the dependencies specified as an argument. Is this make sense?
I'm a little bit lost. I mean, when does that get executed?
When this program is executed. This is what you're asking.
Yeah. I'm going to So am I going to call it 3 times and get the 3 different answers, or I call it once and I get, it goes through the 3 steps and I get the final result, I guess?
Yes.
I don't know.
Yes. But to execute this program is telling you, but you need to specify your implementation for console and your implementation for monad. So first, we can take a look at implementation for this console. For example, here. So IO is from Cat's library implementation for all the execution. So they are providing this as a very something lightweight, like a lightweight thread. This is maybe the best word. Or this is very similar to Monix task, or it relates to JavaScript promise, but it is not promise in a sense that when you call it, when you resolve it once, it will has this value all the time, right? You can resolve it multiple times. This is the difference. But this is implementation of execution flow, or the real like threads and everything, which is inside of that. So when we are saying we are implementing console IO, we are saying with this kind of execution flow, we can implement these methods. And what this means is really calling the real method that is your real standard output, but package up in this effect with this effect function. So it will be inside this IO. So to answer your question, Jim, just calling this function will not do anything, or will not really calling the print to standard output. This will just package up in this kind of box, and we need something from this IO to say, oh, now I have program combined of these boxes, right? I can have multiple boxes, and each box is doing something, and I will combine these boxes with monad one after another, and I can tell this IO, okay, now execute whatever I have in this expression that I combined, right? This is like you have a words, and you create a sentence, and you can execute the whole sentence. So in this way, you can create a program and execute multiple times. Jim, does this make sense?
Yeah, makes some sense. I guess I have to wrap my head around exactly why we're doing things this way, but I guess that's
yeah. I mean, you asked an excellent question, because I jumped. I didn't start from the beginning, and exactly this is the right question. Why to do this?
Yeah.
So,
what problem are we solving?
Say that again, Arthur. What was that question?
I'm asking Tomislav what problem he is trying to solve.
So we want to create pure functions. This is our goal. Oh. So if we are calling print line directly in our program,
okay.
we are depending directly on something that it belongs to our environment or something. So we want to somehow isolate this or create abstraction. And in this article, he's explaining, step by step, why we're doing this and what are the problems. So my intention was to somehow reading this article can be difficult, and I would like to point out to some some parts that maybe I can clarify. And maybe we can talk about this next time, because I think it's very important, and I like it very much, because it's really explained the core problems, what we want to solve, and why this is it can sometimes be difficult. And he's suggesting he's just suggesting that I will jump to the end. this control flow, when it's completely abstract, maybe can be very difficult to understand. So he's suggesting, let's create this control flow, only once. So that it's not completely abstract. So his suggestion is from the tagless final perspective, don't use this F here when defining our abstraction. Don't use this F, but use the fixed type. And his implementation with this Zio is this one type. So he's simplifying this aspect of caring about execution. And with tagless final, this is completely abstract. So this F is a variable. Is a variable, and it can be any type that is created from supplying another type. For example, a list of something, option of something. So we can replace this F really not only by IO. We can replace it by option. We can say, yeah, optionally, I will give you a string, and this will work without problems. So I have example here. Let me put my font bigger. So maybe I can also say something about the syntax, which can also be confusing. What is this? This is some kind of F variable, and then colon here, and it's strange. And then especially this syntax, this is also something that, if you're coming from other languages, this is very strange. For me, that was totally strange thing. So here I'm using task as a execution implementation, and task from Monix, and this is what we are using in RChain project. So this program here, I can run it because task can also support concurrent execution. I can say, okay, I will, whatever this task is doing, I will now tell this program, please execute. So please execute this sequence of actions, of expressions that I created. And when I execute this program, I will see this this execution. And okay, now it's compiling. Okay, so now we see output from here. So this is my implementation, and this is completely the same as in the article. So in my program, I didn't say what will happen for put string. I'm saying this in my implementation, so I can do whatever I want here, right? I can create another implementation that is not using task. Maybe it's using something else. So let me do this. Let me say I'm using option, and the option type is just a type that has where can be seen. Maybe it's not easy to just show. In Scala, some of these types are expressed in terms of Scala also have this object-oriented stuff. So it's not always directly translated for how is in Haskell or So here they're using for the definition of option. They're using extending the product, and But essentially, option type really means I have two possible states, some A or none. So if this pipe is like an OR, so this is one constructor, this is another. So I'm using very simple type for this implementation. So I cannot use task delay here. I want to package up this in this line in my option. So I will say this line, when I have this line, I will just package up this in the option type. And when I have get string, I will do the same thing. Yeah, and here, because this is option of unit, I don't have any way to, what can I do with this line? I can only ignore it. So I can only say unit and put it in a box of option, or I can just say unknown. So this can be my different implementation for a console, which is not really a console, right? I'm just collecting this in the option type. Do you have some questions or?
No, I think I'm following, but I think I'll read the article too when it's over, because I have been, also exposed to all of those monads concept, but I have never really dove into it. So I think I'll check. I did not really understood what a monad is, but I've been exposed to this term for like 3 or 4 years. But I see it as a kind of abstraction. Is it correct?
Yeah, and I would like to talk about this more. Now I mentioned a lot of things, and I know that it's difficult to just catch up all of these things. But now you mentioned monad is of course. What exactly means when you create this for when you sequentialize your expressions? So this code can be is really the translation or syntactic sugar for code like this. So we are doing something here, and then we are calling flat map. And with this flat map, we are accepting the previous result, which we don't care. This is the first. And then we are calling the second operation. And then we are doing the flat map again. And now we have some results from previous execution. So we are specifying a variable because we are just using in the same way how we are using a list, and we are using select many or bind, or this is a different names for the flat map operation, or then in the case of promise. So then in the case of promise is really the same function as flat map, but also then is the same function in promise for map. So map and flat map in JavaScript they are called then on promise. So now I want to call the third expression where I'm using this name here, and that's it. So and at the end I'm returning a name. So I need to do flat map again, where I'm ignoring this last argument, because put string gives me unit here, I don't care, and I'm returning this name, but package up in the box. So this is the same programs, this one and this one, and that's the point of monads. Monad gives you this way of sequentializing programs, but everything is starting to be nested, right? When you have promise, and then you say then, and then you're going inside. So we want to have this syntactic sugar in our language, like async await or for, or in C#, there is a from in. So we have these expressions in the language exactly for the monad purposes. So instead of writing nested things with functions, we have this syntactic sugar, and we can specify this in one scope. I mean, not correctly one scope, but you can see that inside here there is a scope hidden, just like in async await, and that's the monad. That's exactly the monad. This flat map operation, this is a monadic operation, because this flat map accepts a function from, better to show here, from returning argument from the previous box. So it goes inside the box, grab the value, and we are returning again the box. This is exactly what we are doing with promise and then. We have the promise, then, and we are returning the promise.
Okay,
so
is there, okay, so I kind of, now I'm getting it, because you compared with the JavaScript with async await, and so is a monad necessarily related to asynchronous, or can you just do, for example, string manipulation and synchronous operations into a monad?
So you see here that monad is must be in sequence. You cannot say to monad, oh, execute this in parallel or something, right? You must specify, you know, you must open the next scope and the next function, and that's it. So for that purpose, in Scala you have this sync. In cats, Scala cats, you have this sync type, which can suspend operation. So this is important thing. This is the next step. So and most of our code in RChain is with the sync, because you don't want to immediately execute this put string here. So you see that in my implementation here, you have delay. So this delay is concrete implementation of sync suspend. So cats library gives you abstraction of all of this different way of execution, and it specify interface for suspend, and in task they have the same thing, the implementation, right? So when you say sync delay, or suspend has another alias, you have delay. You can suspend execution of this print until is really needed when the whole program is executed. So with this sync and other types, you have more granular ability to specify how you want to execute your program. And from sync, you can go further, and you can have concurrent type. And concurrent type has asynchronous property. In between concurrent and sync is this async, which gives you ability to run things asynchronously. And this is why concurrent gives you this start method to just start another thread, another task. This is not the real thread; it's abstraction over thread, but gives you ability to start something in parallel. But and this is not what monad gives you. So when you go into all the hierarchy, you see that async is implementing sync, and sync is implementing bracket, and bracket implement monad error, and monad error implements the monad here. So there is the whole hierarchy, and the monad is almost at the bottom, because applicative is a little less than monad. Gives you you cannot, with applicative you cannot depend on the previous result. So I would like to also just put a little attention to that, because I can rewrite this program just with applicative. So now this program will not compile because I don't have the monad. So I have less than monad. So in that case, I can only do this kind of operation. So there is a combinator that can be used with applicative. So now I don't have this name, because with applicative I can only specify the sequence of programs, but I cannot depend on the previous result, which is seen here, because now here I'm depending on the previous result. So this program I can rewrite and say, oh, but I don't need to use flat map here. I don't need to use monad here. So I will just use applicative, and I will ignore this one scope. Here I need to use flat map, because I need to use monad, because I'm depending on the previous operation. And at the end, I can just even use functor here. I don't need applicative. I will just map over whatever is here. So now my program is a little simpler, right? Because I don't need that much nesting. And this is what this hierarchy gives us, right? This applicative monad. This is all about the structure of execution. How we are specifying the execution of our program. I hope this will be something that, when reading this article, will be a little easier to understand.
I have a quick question. This cats package, it's not a built-in one, right? It's
this is library. No. This is Scala library.
okay.
Is cats, is that short for category? Or what's cats?
No, I don't think so. It's cats in a sense of well, I'm not completely sure, but yeah, I'm not completely sure. It's more like something that you like, right? Because in RChain we are using cats everywhere, right? It's
Oh, I see. Okay, so it's more of artistic, okay, something that you like, like dogs and cats. So it's Okay.
But I'm not completely sure because Scala is not something that I'm not using Scala for years, so I'm not completely sure. Yeah.
Okay. Well, basic category. Yeah. Well, it's Well, okay. I'm sorry, I interrupted Theo's question. What was
No,
Theo's
I got
question?
my answer. So
Did you get your
in
answer?
order to do what Tomislav just did, we just need this package, right? Before we can code in this fashion.
With Scala, you need this package. Yep. And there are two popular packages in Scala for that: Scala Z, and the cats. And they are in really strong fight. And there were as I understand, there were like harsh words, and they don't like each other. I mean, everybody has its own opinion, and
so there's Scala cats and Scala Z. There are two flavors of Scala. Is that what it is?
Yeah.
Okay.
Not two flavors of Scala, two flavors of this abstraction.
Oh,
so
okay.
this monad sync. So monad is something that is used in mathematics, and
Right.
but these types like sync or concurrent, they are really related to these library cats. So this is also something that you need to learn. When you learn in the library, you need to separate what is really completely mathematics and what is just to support your language in which you're working.
Okay.
And Joe DeGo in his article, he's really complaining about all of this abstraction and why it's difficult to understand, and why is useful for maybe to work with lower abstraction, but to have easy to understand the code. And
it does say cats is a playful shortening of the word category. That,
oh, really?
yeah.
So they started from there. Yeah. Oh, cool. I didn't know that. Thanks. Yeah. Because now they have some library that is dogs and this kind of stuff. And in Scala, I showed you how these arguments are with the colon separated, and to express this kind of programs, we are using lots of Scala nice syntactic sugar, and so this looks very nice, but it's not obvious why and how this works. And yeah, I would like to talk about these specific things, because the first thing is the syntax. When you understand the syntax, you can go further. But if you don't understand the syntax, then it's difficult to understand what is going on. But all of this stuff is really applicable to any language, right? Just by thinking about in these terms, you can understand any language, right? Because you're creating the sequences of expressions then that you want to execute later, and this is your program. So I hope this can be good for introduction, and we can talk about this more in future sessions.
So basically, in functional programming, you have no state, except that monads define a sequence of states. So
there is a special type that is a monad state. So yeah, exactly what you said. When you want to state in functional program, you need to push this state in every execution. You're just pushing from one expression. You have your state, in the background, because you don't want to specify it in every function, right? In every call. So you have it in the background, and this function is flowing with the execution, right? Each call in this flat map will have inside a state. So you will ask your monad, oh, give me the state, or here is the state. Okay, in the next flat map, in the next den, again you have your state inside the monad. You ask, please give me the state, or you push your new state. So you want to hide this state so that you don't need to specify it every time. And of course, if you go, let me. Here is the nice. There is a pretty good documentation for cats. So they're saying what. But there is an even better page. Page with nice images, and is it? Yeah.
Mm-hmm.
So they are saying, what kind of what kind of stuff you need if you want to go in concurrent direction. So when you have a monad, you have a sequence, but this is not enough for concurrency. So this is exactly what Greg is talking about. Why lambda calculus is sequential, and in the same way, just having a monad is also sequential. So with concurrency, we need additional stuff to carry this state, for example. So this is why, for example, in cats we have deferred, and deferred is very, very simple to promise. Get on empty waits. So if we want to get the state inside this defer, we need to wait. On full, if we have state inside already, it immediately returns. So if promise is resolved, we immediately get the value. Complete is calling the resolve on the promise, and the complete on the full fails. So there is like specific rules how this deferred works. So this is like building blocks for creating concurrent programs.
Mm.
And also, for example, we have ref, which is holding the state without locking. So this is like another, you're going further into the direction of concurrency. You have more primitives for execution, because your execution is not just linear, one after another. Now you have branching and then joining.
Good. Tomislav, for leveltypes.org, if you could go back a couple pages and copy and paste that main page in the chat. I'm keeping a record.
I will put all of the links.
Oh,
yeah.
Okay. Very good. We appreciate that.
Yeah.
And I'll put the links in the YouTube video as well for information for everyone who's listening to this.
And I will put two links about tagless final. The first one is by Pavel. He was an RChain developer, and he was pushing the story about tagless final. And I like his presentation. It's really great, and it's talking about the whole path of tagless final from transformers. Mono transformers to tagless, and then B or Zero, very, very similar. And this another talk, I will also mention this one. It's also pretty good. I will put all of the links, so you don't need to,
Yeah, we appreciate that. Thank you.
From the video.
Well, good. All right.
I think this is enough for introduction.
Well, and we're coming up on top of the hour, so this has been great. So in preparation for next week. So one thought. So this is kind of a interesting dynamic where we have an article that we review, on Scala or whatever the topic is, reviewing an article. So one format we could take in the future is if anyone sees an article, or Tomislav, if you have an article that you want to review for an education session, maybe post that article towards the beginning, or a few days ahead of our session in the education channel, so everyone can pull it up and kind of read through it, get so oriented, and then come the day the day of our education system, we'll have a little some background as far as what the topic is. So that's one approach.
Yeah.
So, but any thoughts? So for next week, does as far as what we want to talk about, an agenda, does
yeah, I don't want to talk about, I don't want to take the whole session for that, right? But, each time we can spend, part of the session to talk about this.
Okay.
Just, so that we can, address some questions and, So I will not push too many articles and just say, this is nice and this is nice. So this one article is very good for a few sessions that we can talk about, because it's very general and very important.
Right. And then for next week, do we want to go back to reviewing the code base, or do we want to do the IntelliJ bugging, or do we just want to wait until next week and see where we are? Maybe that's
so. Yeah. What do you want?
Oh, so here was the. Well, let's take a poll of everyone who's on the call, and bear with me here. I'm sharing my screen. So here, these were the options that we had brought forward from previous week. So talking about the code in RChain project, debug in IntelliJ, or have Will speak about RChain. Does anyone have any strong feelings one way or the other as far as next week what we would like to discuss?
I would like to suggest
IntelliJ running, but I don't have debugging set up yet. I need to add configuration. I don't know which one. Like, is it SBT task or?
Yeah. So maybe we can plan to create a short video about that. So
yeah, that would be great.
We were talking about. So, but we need to try to be short, something that you can open, watch in 5 minutes, and So this can be our first experimentation with that, if you are for that.
Okay, so why is that happening? Bear with. Okay, so well, that's going to be interesting how that's going to work as far as. Okay, so we'll make a. So it'll be we'll talk about debugging in IntelliJ. With the goal is to create a short 10-minute video on debugging in IntelliJ. So okay, so
with some kind of description that you can
okay,
you can also copy paste and.
Okay, so understood. So okay, so we'll work on that for next week. Good.
Information for the group. I was able to debug main .scala in Visual Studio Code, but I wasn't able to set a breakpoint in a test and debug a test. For some reason, the breakpoint didn't work.
This is you're talking about IntelliJ, right?
No, Visual Studio Code.
Oh.
Yeah, I can debug main, but I can't. If I put a breakpoint in a test and I run a test, I can't debug. It doesn't stop at the breakpoint. And I put an issue on there on the metals GitHub, but I haven't heard anything back yet.
Yeah, I must say I didn't try debugging with the metals, so I'm not completely sure.
Yeah, it's just interesting. I
Yeah,
I got other problems right now.
yeah. I would think that it's the other way around, you know, because usually debugging tests is easier because you don't need to start everything. But yeah.
Okay.
But it's nice to know that you can debug with metals in Visual Studio Code. This is nice. Yeah.
So then, Steve, when were we going to talk about, like the UI for the contract?
So these are the goals for our second quarter. So
okay.
Yeah, so we don't have a specific day or week assigned. We're sometime between April 1st and July 1st. We're hoping to cover these items. Now, this list may be a bit ambitious, and if it is, we'll just carry it over to the third quarter. But these are just some of the things that we hope to accomplish in our education working group.
Arthur, what?
There was something else that I just wanted to kind of ask the group is that, I keep hearing, when I listen to Greg and sometimes on Discord, we talk about the comprehension and equating that to SQL. And what I'm finding a really hard time with is that SQL, built into the language has both projection and selection, right? So you can project over columns and then you can filter with the select. But with the comprehension, I only seem to be able to do filter with constants. I can't do it with variable values. So it's not a direct equivalent to SQL. And in the examples, it's the pattern does the filtering, but then when you want to do a select, you got to iterate in RChain in a loop to throw away data that you don't want. So it's a little confusing. And I was kind of wondering why that isn't being put into the node, right? I mean, doing that maybe it's so that you can build, but it's really expensive to iterate through a whole bunch of data in order to do.
And one thought, sometimes some of these questions, the only person that can answer them are Greg. So Arthur, it seems like I remember seeing you attending the Casper stand-ups on Monday. Is that correct?
Okay.
Yeah. So what we can do with those types of questions, after Greg kind of goes through what he's been working on, perfect opportunity to say, I have a question on this, and he's more than happy to answer those questions. So, and what's nice is the Casper stand-up is recorded as well. So if you have a question, the chances are there's going to be other people out there in the community who have that question as well, or we'll have it at some point in the future. So by discussing it and working through it, it's everyone can learn from that. So
great.
Yeah, good.
And also I'm looking at some questions we can, maybe Greg wants to cover more abstract view, or so we can dig deeper in our education series.
Okay.
So this is also what would be very nice, because I would like to talk about Greg's code that he's doing right now. But this is not you cannot just easily jump to that and but yeah, I would like to talk about that. Yeah. And you mentioned these comprehensions. These four syntactic sugar in Scala. This is exactly this comprehension. So this is very closely related, and we can definitely talk about this more. I can show you maybe in Python we have comprehensions for creating lists, which are very similar to four comprehensions in Scala.
Mhm.
Good. Okay. Well, welcome, Gurinder. Unfortunately, we're just finishing up, but all this has been recorded and it'll be posted on YouTube for you or for anyone who wants to watch it going forward. All right. So I'll look forward to seeing everyone here. Let me stop
One more
sharing.
thing.
Yeah, go
Sorry.
ahead. Oh, that's fine.
You know, the notion is about, you know, I did that pull request and it was accepted, but I didn't feel comfortable about having followed a particular prescriptive process. So I wasn't sure if I was good or bad or if I should do something else. So, you know, I mean, I'm assuming we debugging
sorry.
with Scala contribute, right? But I'm not 100% sure what that workflow is for contributing.
So you pushed your PR, but it's still not merged. I'm sorry.
I thought it was accepted.
So it must be approved by two developers.
Okay.
And after that, we can call our boards bot to really do the merge, and so that code will go into the dev branch and then into the next release. And we, you know, three of us are just don't have enough time to do all of these things, and that's the only problem. So sorry about that.
No, I don't think that's, you know, that really is my problem. My problem is I don't have a repeatable workflow to follow to do a request into RChain. I just don't. I mean, you know.
How do you mean a repeatable workflow? I'm not sure exactly.
I don't know if I should create a Jira issue first. You know.
Yeah, for now, we are thinking to migrate to GitHub so that we can have issues in GitHub and you know, related pull requests. So for now, workflow that, you know, we have from previous developers, we are creating Jira ticket with some description, and then when we are creating PR, we are adding this link to Jira ticket in this description of PR. And usually I just copy the description from the ticket to description in PR.
But then I had to set up a what was it, a GPC, like some public key thing that I had to upload to GitHub. Is that still required?
Yeah, this is for signing the commits.
Okay, so all that's still valid, right?
Yeah.
Okay.
Yeah.
Okay, here I'm gonna stop the video.
And this is the workflow. This is the workflow practically on any GitHub repository. It's very similar.
Okay.